Welcome back, students. In this video, we're going to cover Module 5, Topic 6, Isosceles and Equilateral Triangles. This is on page 20 of the Module 5 packet. Standard for this topic is GR 1.3, prove relationships and theorems about triangles, solve mathematical and real-world problems involving postulates, relationships, and theorems of triangles. Objective for this lesson, you guys are going to solve problems involving isosceles and equilateral triangles. Going to change things up this video. I am going to skip the warm-up. This is a bit of an experiment on my end. If you, the type of problem this is, if you want to know how to work this, go back to the previous video. Let's see. Previous video, Module 2, we talk about slope and the distance formula. You're going to need that for that warm-up. So, but for now, we're going to skip that. We're going to move down again, page 20 in Module 5 packet. Let's see. Give me just a moment, guys. I apologize. I should have wrote this in as I was mumbling on. Let's see here. Color in some stuff, then we'll read this little bit and talk about what we're going to learn in this particular module or topic. Okay. An isosceles triangle is a triangle with at least two sides congruent. The two congruent sides are called legs of an isosceles triangle. Excuse me. The angle between the sides, this angle here, angle 1, is called the vertex angle of the isosceles triangle. Angle 1 is the vertex, I just told you. The side of the triangle opposite the vertex angle, so right down here, it's called the base. The two angles formed by the base are in the congruent sides, so angle 2, angle 3. Those angles are called base angles of isosceles triangle. Angle 2 and angle 3 are those base angles, just like I said. So, Theorem 5.10, isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. So, this guy would be congruent to this guy. It says if AC is congruent to BC, then angle 1 and angle 2 would be congruent. Let's move down just a little. The bottom 5.11, the converse of the isosceles triangle theorem. So if two angles are congruent, two angles of the triangle are congruent, then the sides opposite those angles are congruent. So side opposite. Just like, looks just like that. So it's just the converse. The theorem talks about sides to angles. The converse talks about angles to sides. That's that whole P, then Q, Q, then P thing we talked about in Module 3. So let's flip over. Page 21 of this packet. Let me get my page lined up, excuse me. All right, solve for the missing angle measurements. All right, so we just talked about that if the two sides are congruent, so, you know, these two sides are congruent, then the base angles had to be congruent. So if this guy is 80, and they're congruent, this guy's 80. All right, and if these two are 80, so if the whole triangle is 180, this guy's going to be 180 minus 80. 80 plus 80 is 160. So 180 minus 160 is 20 degrees. So this one's 20 degrees. All right, number 2. So you do. Please pause the video here or try to work this problem. I'm going to wait 3 seconds before I continue. Once you're done, let's see how you did. All right, number 2. Solve for the missing angle measurements. So again, if these two sides are the same number, 25, that means they're congruent. If those two sides are congruent, this angle here is 30, So this guy over here would be 30. This one up here, of course, they're all three 180. 30 plus 30 is 60, so 180 minus 60 is 120. And that's what this guy is. Okay, number 3. Page here. Is a triangle ABC an isosceles triangle? We're going to have to determine if we're going to get the measure of angle C and angle B, and then we're going to determine the length of AB and AC, because if it's an isosceles, these two angles have to be congruent in those two sides. I know I just said it backwards and pointed backwards, but so if this guy up here is 70, we know the whole triangle is 80. So 180 minus 70 is 110 degrees. So that means both of these together equal 110. We'll just say measure of angle C plus the measure of angle D equals 110. If they're congruent, because we're going to assume and then we're going to try to prove it that these angles are congruent, then that, so they equal, so 110 divided by 2, that's going to make both of those angles 55 degrees. So the measure of angle C is 55 degrees. The measure of angle D is 55 degrees. Okay? So now, if these angles are congruent, these sides have to be congruent. So let's check. So we have the distance formula. Y sub 2 minus y sub 1 squared plus x sub 2 minus x sub 1 squared. Sorry, we're getting a little messy down there. Just going to flip down here. Well, actually, I need my points. I need A is 0, 1, 2, 3. So 0, because it was on there, 3. C is -1, -2, -3, -4, -1, -2. So -4, -2. And then B is positive 1, 2, 3, 4. 1, 2. 4, 2. All right. So AC. We've got -2. So these are going to be, let me just do this. I'm going to make A my x1, y1. So that'll make this my x2, y2 when I do that one. B will be my x2, y2 when I do that one. Okay? Everybody with me? All right. So move down here just a little bit. So y2 is -2 minus y1 is 3 squared plus x2 is -4 minus 0. -2, -3 makes -5 squared. -4 minus 0, -4 squared. 5 squared is 25. -4 squared is 16. 25 plus 16 makes square root of 41. Just scoot. You guys are going to have to trust me on the points because it's up above us now. So now we're going to check AB and see if these guys are congruent. So looking up above, my y's are -2 minus 3 squared plus the other side. I think I took, yeah, C was -4. Yeah, that's right. Okay. Yeah, this is positive 4. Sorry. All right, just double checking something. So my x's are 4 minus 0 squared. -2, -3 make -5 squared. These numbers are looking really similar. 4 minus 0 is 4 squared. -5 squared is 25. 4 squared is 16. 25 plus 16 is still 41. So these two are congruent. So go back up the page. So are they congruent, or is it congruent? Yeah. I mean, is it an isosceles? Yes. Why? Well, because these sides are congruent and those angles are congruent. That's how we prove it. All right, number 4 is a you-do. So please pause the video here. I'm going to wait 3 seconds. Once you're done, see how you did. All right, number 4 is the triangle below an isosceles triangle. So we got a right angle here. So mark that. Determine the measure of those other two angles. So so the whole triangle is 180, this guy's 90, so that makes these other two 180 minus 90 is 90. So if the measure of angle XYZ plus the measure of angle YZX equal 90. Well, if they're congruent, because we're assuming it's isosceles, 90 divided by 2 is 45 degrees. So angle XYZ and angle YZX both equal 45 degrees. Okay, so we got this. Now, our points. So no X, we're straight up the Y-axis. So Z is going to be 0, 1. See, it's 1. Y is up here at 0, 1, 2, 3, 4, 5, 6, 7. 0, 7. And then X is out here at -1, -2. So -3. Then we go up, so positive 1, 2, 3, 4. Okay. Back to the red pen here. So now we're going to distance formula to get XZ and XY. I'm going to write the distance formula again. It's right there. The points, I'm going to scooch here. You have to trust me. XZ is first. So it's going to be 1 minus 4 squared plus 0 minus -3 squared. So 1 minus 4 is -3 squared plus 0 minus -3, that's 0 plus 3, that's 3 squared. 3 squared is 9, -3 squared is 9, positive 3 squared is 9, 9 plus 9 is 18, so XZ is the square root of 18. Now we're going to do XY. Let's see if they're equal, and then we'll know that they're isosceles. So 7 minus 4 squared plus 0 minus -3 squared. 7 minus 4, that's 3 squared. 0 minus -3, that's 3 squared. 3 squared is 9. 3 squared is 9. 9 plus 9 is 18. And square root of 18 and square root of 18 are equal. Go back up the page. Or is this an isosceles triangle? You betcha. And that, folks, is the end of. Hold on. I make sure. No, I got one more page. Yeah, actually, I'm gonna split this in half. I just realized this is gonna be. Let me just hold on. Actually, I'm just gonna go ahead and finish the topic. We didn't finish it in class. I split it in half, so we'll do it the right way in the video. So that's the moment. Got a little discombobulated because I was thinking I was done. Should have split it in half, but that's okay. All right, so to prove the isosceles triangle theorem, we're going to draw an auxiliary line, use the two triangles that are formed to prove that it's an isosceles triangle. An auxiliary line is an extra line or segment drawn in a figure to analyze geometric relationships. In this case, it's going to be this dotted line LM. And you'll see what I'm saying as we get down here. Let me reposition. So number 5. We've got a proof here. It says given is that triangle LMP, and that LM and LP are congruent. LM, LP. So before we even get down here, notice this dotted line is going to belong to both of these triangles because we're turning 1 into 2 with that line. That line is congruent to itself because reflexive, and that's going to be down here. Spoiler alert. So we got those two things handled. All right, so statement 1 says let N be the midpoint of MP. And it's because every segment has exactly one endpoint. So these guys are going to be congruent to each other. Draw an auxiliary line. Got that. 2 points. Any 2 points determine a line. Cool. Number 3, MN is congruent to PN. PN. Why? Well, because it's a midpoint. Look down here, our word bank is a little bit below, but we have midpoint theorem. All right, number 4. So we're looking for the statement reflexive. Ln. Ln is congruent to Ln. Of course, that's down below, but it says, and actually it says the angle, but it's the line. All right, number 5. Lm is congruent to Lp. Well, that's given. Waited to statement 5 to tell us that, or ask us that. 6 is given both sides, or they gave us this both sides, that the triangles are congruent through side, side, side. We see that. And so now we got an extra one here. It says that M is congruent to P, those angles. Let's see, for these angles. And the only thing left in the word bank, I'm just going to scoot it so you guys can see it. We use this, we use the other 3, but it's CPCTC. And remember from previous lesson, CPCTC is the corresponding parts of congruent triangles are congruent. So we know they're congruent because we proved it in this statement. And because we know that, then we can say these other 2 angles. That was the corresponding ones I showed you before we pulled the screen. Okay, number 6. This is a you do. I'm going to ask you to pause here. Please try this. I'll wait 3 seconds and continue. See how you did after you're done, but do try to work it on your own, please. All right, number 6. Golf flags. So each hole on the golf course is marked with a triangular flag as shown in the picture. Points F, G, and H are the vertices, or the angles of the flag. KH, that's the dotted line in the middle, it bisects angle, let's say angle GHF, so this angle. So that's going to be that these 2 sides of H are congruent. I'm marking all the way through it, but you can't see it. It's black and white. Let's see, perpendicular bisector. So it means that the box is on both sides of that. Again, I'm kind of overdrawing so you can see it. And of course, in the middle, this line in the middle, hopefully you can see that. I'm just about out of, yeah, there you go. Line in the middle, of course, goes to both triangles. So KH bisects that angle. That was given. Says the second given. So that bisects. What else did they give us? Let's see. Hold on. Oh, bisects that and is a perpendicular bisector. Oh yeah. So down here, you have to go below. KH is a perpendicular bisector. That's the other, the given. Perpendicular is this little symbol here. Okay. Check the pins here. GK is equal to KF, and that's the definition of a bisector. So yeah, forgot to mark that one. So definitely make mistake, guys. Let's see. So we'll mark it that way so we can see those. We'll mark it with the orange, GK and FK. And it's because of the perpendicular bisector. Excuse me. All right. So number 4 says definition of congruent. Well, what does congruent mean? It means equal. So if this was equal, that means we're going to go GK is congruent KF. GK is congruent to KF. So the bisector. All right. So next it says definition of an angle bisector. Well, if the angle bisector, it means it's going to talk about the angle that it bisected. That's GHK is congruent, and they're congruent because it cut that angle in half. FHK. Okay. Third angles theorem. So there's only one set of angles left here, and that's G and H. And if you look up at the diagram, you'll see that that's the third angle of each triangle, and those are congruent because if the first 2 angles are congruent, the third has to be. And the last thing is the converse of isosceles triangle theorem. And that's going to be that those sides, let me just pull it up here. So these sides of the congruent angles, so GH and FH. So GH, FH. Okay. Okay. Flip over here. We didn't do this in class. I cut this off to even up the two lessons that were remaining. So page 23, corollaries. The isosceles triangle theorem leads to two corollaries about angles of an equilateral triangle. So corollary 5.3, an equilateral triangle, a triangle is equilateral if and only if it is equiangular. So, excuse me, that means so if the three sides are congruent, so just like we were talking about with the isosceles, those two angles were congruent because those two sides, and these all three sides, I know I did these in different colors. It's the same as if they were all the same. In fact, I'll do the angles that way. Let me do this color. So, because all three sides are congruent, all three angles are congruent. There we go. And so that leads us to corollary 5.4, that if each angle of an equilateral triangle is going to measure 60 degrees. So because 180 divided by the 3, the only way you can do it is 60. So this would be 60. That makes everybody 60. Sorry about that. Sorry, guys. I was trying to pause this and didn't hit the pause button. So sorry for the dead air. I'm actually going to stop the video here. I'll pick up the remainder of this page 23, and then we'll knock out the last two pages, which is topic 7 in the next video. It's after midnight on Saturday morning, and it's just best if I stop here, guys. So have a good night. If you got any questions, send me a message or ask me in class, and have a good evening.